This is the sixth video in our series of balancing equations where we're following the law of conservation of matter when balancing out chemical reactions. And in this video we are going to take a look at this double replacement reaction between ammonium phosphate and lithium hydroxide. And we are going to have to use our rules for naming compounds and bake this into a chemical reaction with formulas rather than names. We're going to look at this first element, and we notice that it's not an element, it is a polyatomic ion, and it is attached to another polyatomic ion. Okay, I know it's a polyatomic ion because of this ending. We go to this is an element, but hydroxide is also a polyatomic ion. So let's go to our list of polyatomic ions to get that information. If we look on this list, we'll see that ammonium is NH4 plus, phosphate is PO4 -3, and hydroxide is OH negative. So all we need to do is find lithium. All right, let's go back and write down what we found there. Ammonium is NH4 plus, phosphate is PO4 -3, hydroxide is OH negative. All we need to do is find lithium. If we go to the periodic table, we will see that lithium is right here in the first group. It has one valence electron, which it will lose to form a +1 cation. We can go back here and write down the lithium cation next to the polyatomic anions that it is bonding with. Now what we need to do is figure out in what ratios do these ions combine to form compounds. And we can do that using the cross and drop method. We will need 3 ammonium ions to every 1 phosphate. This is a 1-to-1. This is also a 1-to-1. And over here we will need 3 lithium to every 1 phosphate ion. So this will combine. We have to put NH4 in parentheses, the 3 outside the parentheses, and it will combine with 1 phosphate ion. Lithium and hydroxide combine in a 1-to-1 ratio, as does ammonium and hydroxide. And then over here we will need 3 lithium ions for every 1 phosphate ion. So there we've got our chemical equation with formulas. So now we can go ahead and balance that equation. And we do that in the same manner that we have in the last few videos. We are going to separate products from reactants. We're going to remind ourselves that we can only change the coefficients, not the subscripts. And we will write out what we have on both sides. Only this time, instead of writing out each individual element, because the polyatomics stay together on both sides of the equations, we are going to write out the polyatomic ions. So we have ammonium, we have phosphate, we have the lithium ion and the hydroxide. And we'll put them in the same order on this side. Okay, same idea. We're counting, but in this instance, instead of counting atoms, we are counting ions. Over here we have 3 ammonium, 1 phosphate, 1 lithium, 1 hydroxide. And on this side we have 1 ammonium, 1 phosphate, 3 lithium, and 1 hydroxide. we have to change ammonium from here to here. We have to change this to 3. So we're going to put a 3 in front of this compound, which will change this to 3 ammonium ions and 3 hydroxide ions. Now we've got 3 lithium and a hydroxide on this side and only 1 on this side. So we're going to put a 3 in front of this, and that will change both lithium and hydroxide to 3. Double check our work. 3, 3, 1, 1, 3, 3, 3, 3. We are balanced.